At the time of the OPF burn, Orion will be 328 statute miles above the moon. And then just a short time from then, Orion will complete its closest approach to the moon at 81 miles above the lunar surface. Now, during this time, we will not have signal with Orion because it will be traveling behind the backside of the moon. However, we expect to regain communications once Orion swings back around to the other side and is back on the deep space network. The outbound powered flyby will send Orion close enough to the lunar surface to leverage the moon's gravitational force and swing the spacecraft once around the moon toward entry into what we call a distant retrograde orbit. Following this, Orion will remain in the distant retrograde orbit for one long elliptical orbit around the moon, lasting about 6 days. Now, this orbit is called distant due to the high altitude from the moon. It's about 40,000 miles past the moon in its orbit, which is actually 30,000 miles farther than the previous record set during Apollo 13. And this will be the farthest in space any spacecraft built for humans will have ever flown. This orbit is also called retrograde because Orion will be traveling around the moon opposite the direction the moon travels around the Earth. This DRO provides a highly stable orbit where little fuel is required to stay for an extended trip in deep space in order to put Orion's systems through its paces and to the tests in an environment far from Earth ahead of crewed flights.